So we have a couple more things to talk about. What else should we look out for when we do these hypothesis tests or confidence interval calculations? Number 4, the margin of error in a confidence interval only accounts for random sampling errors. So that's just a matter of if you repeat the sampling process, you don't get exactly the same value of x bar each time. That's why we have a margin of error to help that capture the true mean. If the data does not represent the population, there's no way to draw conclusions, and confidence intervals or hypothesis tests will not give valid results. So the most important thing is that you have something like a simple random sample from the population, so that sample has a good chance of representing the population. Without valid sampling, then nothing you do afterwards can actually be useful. So if you haven't done sampling in an appropriate way that approaches simple random sampling, then chances are the results will be biased in some direction, and then you can't use confidence intervals or hypothesis tests to say anything about where the population mean actually is. It cannot be fixed. Number 5, the usual level of significance is alpha equals 0.05, and its partner, the confidence level, is 95%. However, pay attention to the sample size. Large samples can make small changes statistically significant, and those small changes might have no practical significance. So you might be trying to detect, say, whether a kind of fertilizer increases the yield per plant of potatoes. A large enough sample will make very small changes statistically significant. I would say that the fertilizer is helping. It's not random variation, but if the change is so tiny that it doesn't really matter, it's just a tiny increase in yield that you can pretty well be sure is not a random increase in yield. It might be so small that it doesn't matter, especially if the new kind of fertilizer costs a fair bit to apply and you're only getting a fractional increase in yield per plant. So you'd say, yes, I found the increase statistically significant, but it's small enough that it really doesn't make any difference in terms of the operation of my business. And then, small samples can make important changes not statistically significant. So if you can only sample maybe 10 observations, and you're looking for a change that's meaningful to you, but it may not be enormous percentage-wise. For example, say you were trying to raise a test score, and the mean test score is 50, and you managed to raise the test score maybe 5 points through some kind of intervention. When you try to determine whether that intervention was working with a small sample size of, say, maybe size 10, that size change might just look like it could be random variation, even though it might be meaningful. So we have to make sure we have a large enough sample to detect changes we would like to find, and not such a large sample that we detect things that aren't meaningful to us. There's 2 things you might try to keep those things from going wrong. One is use the sample size formula for confidence intervals to see what n should be. So that'll make sure we don't have too small a sample if we're trying to detect a difference on this in these range of the margin of error level. So if you want to know, like, within maybe 1 or 2 points what the mean is, so you can make the margin of error 1 or 2 points and figure out what n has to be to make that happen. We can also compute a confidence interval for mu in addition to performing any hypothesis test you might do. The confidence interval will tell you where you think the true mean is, and that helps you take care of this problem, that you'll now see that, yes, the mean isn't what it used to be, but the interval's so narrow that it doesn't encompass the old value of mu. But the value it does encompass is pretty close to the old value of mu as far as practical concerns are related to the problem. So having a confidence interval in addition to the hypothesis test will give you more information about where mu is. And that might tell you, on the one hand, if you have too small a sample, that the range of values for mu that are possible include values you think are appropriate and ones that are not appropriate. And so you would like to narrow that down by increasing the sample size. Or the range of values that mu has to fall in is so narrow that it seems to be different from the old mu, but it's not different by enough that we care. And those are the things we have to worry about when we do sampling and hypothesis testing and confidence interval creation. And we're going to move on in our next life to find a way to get rid of that need for the sample, for the population standard deviation in our testing and our confidence interval setup. So we're going to move on to things you can actually do with real data where you have no idea what sigma is. It's coming up, but not right now.